In this definition, we took the quotient of a group, modulo it's a normal subgroup, and gave this quotient the structure of a group again by means of this group law here. So let's check that this is actually a group. What about closure? If we take two elements, G1, G2, in our group, then G1, G2 times H is of course again in the quotient group. It's a coset. What about associativity? Well, we get that from associativity of the group. So if we spell this out, then G1H times G2H and the result times G3H is the same as G1, G2H times G3H, and that's by definition the same as G1, G2 result times G3H. Now, associativity in the group means that we can move the parentheses here. So G1 times G2, G3, the last product first, and the whole thing times H, and that's G1H times G2, G3H, and that's the same as G1H times G2H times G3H. But now the last product has to be performed first. What about the neutral element, the identity in our quotient group? Well, the identity is the subgroup H itself. Why is that? If we look at H times GH, that's the same as EH times GH, and that's the same as EG times H. So that's just again GH, and that works also if we write GH times H, of course. So this is the identity. And what about inverses? Well, G inverse H is the inverse of GH. And that we also get from the group again. So G inverse H times GH is the same as G inverse G H, and that's EH, and that's just H, the neutral element in the quotient group.